Welcome viewers. In this module, I am going to talk about introduction of IoT. So this is the plan of my video. In this, I am going to cover what is Internet of Things, how Internet of Things works, then current status and future prospects of IoT. Then I will discuss about the knowledge management from data and wisdom. Then um, I will just discuss a few future of IoT, potentials of IoT and their applications. Finally, the technological challenges and criticism and controversies for IoTs. So let's begin. Let's start with the understanding of IoT. The IoT is a network of physical objects or things embedded with electronic software, sensor, and network connectivity, which enable these objects to collect and exchange data. So that simply means IoT is the network of physically connected devices, which those devices are able to communicate with each other over the internet. So IoT allows objects to be sensed and controlled remotely across existing network infrastructure, creating opportunity for more direct integration between the physical world and computer based systems, and resulting in improved efficiency, accuracy, and economic benefits. So let us understand what is things. In the IoT sense, it can refer to a wide variety of devices such as heart monitoring implants, biochip transponders, or on farm animals, electric clamps in coastal water, automobile with built-in sensors, DNA analysis devices, for environmental, for food, pathogen monitoring, or field operation devices that assist firefighter in search and rescue operations. So in short, things means any object which do not require a specific name. It can be a table, it can be a chair, it can be a wall, it can be anything. So these devices collect useful data with the help of various existing technologies and then autonomously flow the data between other devices. So this is the history of IoT. The concept of IoT became popular in 1999 through the Auto ID Center at MIT and related market analysis publications. So radio frequency identification. This radio frequency identification came in existence in 1967 uh, when it was seen as a prerequisite for IoT at that point, just to collect the information. So if all objects and people in daily life were equipped with identifier computers, could manage and inventory them besides using RFID. The tagging of those things may be achieved through such a technology as near field communication, barcode, QR code, Bluetooth, and digital watermarking are the examples of it. Now let us understand what is how the IoT works. Internet of Things is not the result of single novel technology. Instead, it's a combination of all complementary technical developments. Those are having some specialized capabilities. The capabilities includes communication and cooperation. Next is addressability. Next is identification, then sensing or actuation, then embedded information processing, localization, and user interfaces. So these are basic components involved in IoT. In that, one example is demonstrated here with the help of RFID. So RFID stands for just to identify and track the data of things. Next, role of sensor is to collect and process the data to detect the changes in the physical status of things. Smart technology here plays a role to enhance the power of the network by developing processing capabilities to different part of the network. And nanotechnology is to make the device smaller and smaller. So we have the ability to connect and interact. Next is the structure of IoT. The IoT can be viewed as a gigantic network consisting of networks of devices and computers connected through a series of intermediate technology, where numerous technologies like RFID, wireless connections may act as enablers of this connectivity. So it involves tagging things. So real time atoms traceability and addressability by RFID. Next is feeling the things. Next is shrinking the things and thinking the things. This is the structure of IoT. Now let us understand what is the current status and future prospects of IoT. In 2003, there were 6.3 billion people in the world who use different devices, out of which 5 million devices were connected through the internet. Now in 2020, there are 7.6 billion people in the world, and they are using 50 billion devices which are connected with each other. And definitely the mean for communication is internet, so we can call them as a internet of things. So, connected devices per person, if you compare, in 2003 it's 0.08, whereas in 2020 it's 6.58. So, you can observe more connected devices than people in 2020. So, change is the only thing permanent in the world. So this is one of the typical scenario of IoT network of networks, in which business is at the center. All around we can find educational environment, then transportation, energy systems, other industries, then earth, then home automations and home security systems, smart home systems. So all those systems are interconnected with, and they are around of these businesses. So this network connected with added security analytics and management capabilities, this will allow the IoT to become even more powerful in what it can help people to achieve. So this is the knowledge management that is turning data into wisdom. So we have bottom end at data, then it can be converted into information, it gets converted into knowledge, then understanding and wisdom. So the more data that is created, the better understanding and wisdom people can obtain. So the future of IoT, what happen when 50 billion machine become connected? So this is a typical scenario. Here, most of the objects are interconnected with each other over the internet. So by observing this scenario, we can say the sky is not the limit, it's only the beginning of IoT. The potential of IoT, value of industrial internet is huge. Connected machines and data could eliminate up to 150 billion dollars in waste across industry. So this estimates on a potential of just 1% saving applied using IoT across global industry sector. To unlock the massive potential of IoT, we should understand improved performance, reduced cost, create innovative services, and new revenue stream. This is the technological roadmap of IoT. This is how we began at 2000. RFID tags were used to facilitating routing, in inventory and loss prevention. Sorry, in 2010 it was surveillance, security, healthcare, transportation, food safety, document management. Now by the 2020, locating people and everyday object, and other one is teleoperation and telepresence ability to monitor and control distant objects. So still the development is continued, and many more things are there to achieve. Now, applications of IoT. There are variety of applications in different domains for this IoT. You can find different things at smart homes. You can find different applications at smart cities. You can find wearable applications, etc., which we have covered in previous video. Few additional applications are enlisted here. So these are building and home automation, manufacturing units, medical and healthcare systems. Then social media are one of the example. Uh, Environmental monitoring, infrastructure management, energy management, transportation, and better quality of life for elderly. So you name it and you will have it on IoT. So these are diverse applications. Just in addition, you can find this in home consumer. You can find it in transport, mobility, health. That is in healthcare industries. Then buildings, infrastructure, and different cities. These are the applications. So create 41 billion USD. So IoT, one of the example is smart parking. You can find in small space. You can have many as much as possible vehicles parked in a single parking slot. So this is the efficient waste management scenario in smart cities, supported by sensing as a service. Sensor, even the holy cow, in the word of IoT, even the cows will be connected and monitored. Sensors are implanted in the ears of cattle. This allows farmer to monitor cow health and track their movement, ensuring a healthier, more plentiful supply of milk and meat for people to consume. On average, each cow generate about 200 MB of information per year. So of course this is additional about the information. So in Internet of Thing is the next stage of information revolution, and referenced the interconnectivity of everything from urban transport to medical devices to household applications. Integration with the internet implies that devices will use IP address as unique identifier. However, due to limited address space of IPv4, which allows only 4.3 billion unique addresses, objects in the IoT will have use IPv6. So objects in the IoT will have to use IPv6 to accommodate the extremely large address space required. So objects in IoT will have only be devices with sensory capability, but also provide actuation capabilities. On the other hand, IoT systems could also be responsible for performing actions, not just sensing things. Intelligent shopping systems, for example, could monitor specific user purchasing habits in store by tracking their specific mobile phones. These users could then be provided with special offers on their favorite products, or even location of item that they need, which their fridge has automatically conveyed to the phone. Additional example of sensing and actuating are reflected in applications that deal with the heat, electricity, and energy management, as well as cruise assisting transportation system. Other applications that the Internet of Things can provide is the enabling extending home security features and home automation. So these are just additional applications mentioned over here. Another application scenario of online shopping. So this is another application. So just to keep a track of how many steps you have walked today can be tracked, and you can maintain the record of it, so that every day you can keep on improving yourself as far as walking is concerned. How well do I sleep? So this is also can be tracked with the help of IoT. If you have a smart wearable wristband, it can keep a track of it. So I want to know more about myself. So how it is possible with the help of IoT? So IoT helps you in lifelong logging. Thought controlled computing is also possible if you can consider this scenario, but this can be implemented in near future applications. So technological challenges of the IoT. So at present, IoT faces many of the challenges such as scalability, technological standardization, interoperability, discovery, software complexity, data volume and interpretation, power supplies, interaction and short range communication, wireless communication, and fault tolerance. These many are the challenges which are the hurdles, or you can say the obstacles in the development of IoT. So big data is not a magic. It doesn't matter how much data you have if you can't make sense of it. So criticism and controversies, these are listed here. So, scholars and social observers of pessimistic behavior have a doubt about the promises of ubiquitous computing revolution in the areas of privacy, security, autonomy and control, social control, political manipulation, design, environmental impact, and influence human moral decision making. So, just to summarize, we have talked about the history of Internet of Thing. We discussed what is IoT, what are different structures, what are the components of IoT. Then we discussed how the IoT can help in the improvement of businesses, how it can help in different environment to improve the data acquisition systems, etc. Then we talked about the different applications of IoT in different domains. So after that we studied the challenges and criticism for this IoT. So these are the references I have taken for making the video. So guys, thanks for watching this video.